Alright, so hi guys. I want to apologize in advance. My headphones aren't working. Actually the mic of my headphones isn't working, so I am doing this without my headphones. Hopefully y'all can still hear me. But in this video, we're gonna go ahead and do this problem. By the way, guys, I hope everybody had a happy new year. Sorry for the lack of uploads, I've been so busy. So, it says find the limit by L'Hopital's rule. And this one, I will admit, was a bit tedious to do. But I'm gonna go ahead and explain it to you guys, as best as I can. So, here we have the limit as x approaches 0 of x times the quantity cosine of x minus 1 over sine x minus x. So give me 1 second, guys. Okay, so here we have L'Hopital's rule, right, guys? Here says if the limit as x approaches a of f of x over g of x, which equals 0 over 0, this is one of the indeterminate forms. I want to emphasize that there are other ones, but in this one we're gonna focus on this indeterminate form of 0 over 0. Then the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x, such that f of x does not equal g of x. And if it does, it would be 0, but anyways. Actually, if it does, it would be 1. But anyways, usually they don't give you the same function on top and bottom. So again, here we have limit as x approaches 0 of x times cosine x minus 1 over sine x minus x. Since it already tells us to find the limit by L'Hopital's rule, we don't need to test to see whether we have to do L'Hopital's rule or not. So, we're gonna go ahead and do L'Hopital's rule. So the first thing we're gonna do, okay guys, we're gonna go ahead and find the derivative of the top. So I wanna emphasize, guys, it's important that y'all know how to do the product rule for this. I do have some examples of product rule in, I believe, my calculus playlist. But yeah, so I'm not gonna really go over the detail of how to do that here. But what we're gonna do, we're just gonna say the limit as x approaches 0, then it's gonna be 1. So we have 1 times, so it's going to be 1 times cosine of x minus 1, so the derivative of the first times the second, plus the derivative of the second, which is negative sine x. You want to make sure to put all of this times x, right, guys? And then on the bottom, we know the derivative of sine is cosine, and then the derivative of x is just x. I like to write it this way, guys, just so we don't get confused into thinking that it's cosine of, like, all of x minus 1. Because, yeah, it's better to write it this way. So, let's go ahead and simplify this. We get cosine of x, limit as x approaches 0 of cosine of x minus 1, minus x sine of x over cosine x minus 1. And again, if we try to evaluate this, guys, you want to go ahead and try and evaluate this just in case it gives you 0 over 0 again. So obviously we get 1 minus 1 minus 0 over 1 minus 1. So this is 0 over 0, right? It's not going to work. It is still indeterminate. Indeterminate form. So then we do it again. So the limit as x approaches 0, we're gonna now do the derivative of this, right? So it's going to go negative sine x. And then the negative 1 will cancel out, so it's going to be minus 0. And then the derivative of negative x sine x, we're just going to say minus parentheses 1 times sine x. And then plus x cosine x. Okay, guys. So this, again, is a very tedious problem. You have to do L'Hopital's rule a few times to get this one. It took me a good 5 minutes to do it on my own. Or a good 10 to 20 minutes. But again, I figured it out. Yeah, so here we're going to go ahead now and now do the derivative of the bottom. So we're going to put negative sine of x here. And then we're going to continue. So limit as x approaches 0. It's going to go negative sine x. And then minus, you're going to distribute. Okay, guys. So this minus 0 goes away. So this becomes no more, right? Let's just take that out. And then minus sine x minus x cosine x. Okay, all over negative sine of x. So you want to remember, guys, not only do you take the derivative of the top, but also the bottom. So that's something that I made a mistake on. Okay, so we need to remember to do that. So we go ahead and do that. Okay. And then we're going to go ahead. Now, let's go ahead and combine like terms, guys. We're going to do negative, so this right here, the limit as x approaches 0 of negative 2 sine of x minus x cosine of x over negative cosine of x. Now factor out the negative, right? So we have, again, let me go ahead and rewrite it. Hold on, guys. So again, factor out the negative. So limit as x approaches 0 of negative parentheses 2 sine x. So be careful with your signs. Plus x cosine x over. And we're going to say negative 1 times cosine x. So obviously we cancel that out. We get the limit as x approaches 0 of 2 sine x plus x cosine x. Give me a second. Over cosine x. Sorry, guys, hold on. So again, if we evaluate this by direct substitution, it still gives us the same thing. You can test it if you want. If you can't do this in your head, like the actual substitution, you can do it by, you can literally write it out and see that. So it's still the same thing. Actually, hold on, guys. Did I make a mistake here? Oh, Lord. Hold on, guys. Oh, my God, I knew it. I made a mistake, guys. I'm sorry. This is a really tedious problem. I always tend to do that. This is supposed to be negative sine x. I'm sorry. Lord. That's what I mean. Over negative sine x. And I don't know why. Okay. So, yeah, I'm so sorry, guys. Like I said, this is a really tedious problem. As y'all know, I'm not perfect either. I make mistakes. So it's supposed to be negative sine x instead of negative cosine x. So you have to be really careful, okay? Limit as x approaches 0 of negative the quantity 2 sine x plus x cosine x. So you're just factoring the negative out. Okay, guys? So, and then over negative the quantity sine x. So now take these two out. So you have 2 sine x plus x cosine of x over sine x. So then this is going to be 2 sine. So again, if we evaluate this, it's still going to give us 0 over 0. You want to make sure to evaluate it every time, guys, just in case. Because if you do end up finding the derivative, you don't have, or if you do end up finding the limit, you don't have to do it again. Okay, and that's what a lot of people, I mean, that's one mistake that we must not do. And where if you do find the limit, you're done. You do not do L'Hopital's rule again. So always evaluate every time. Or every time you take the derivative of top and bottom. So let's do it again. So it's going to go of 2 cosine of x plus, and again, we're going to do 1 times negative sine x plus times cosine x. Oh my god. Plus negative sine x times x, and then so like this, and then over, and then remember to take the derivative of the bottom over cosine x. So then this gives us the limit as x approaches 0 of 2 cosine x plus cosine x minus x sine x all over cosine x. I think. Okay, so then we're gonna go ahead and now finally evaluate. So by direct substitution, this is equal to 2 cosine of, excuse me. You can direct substitute here, but you can just simplify it a little more, just to kind of not have as many, expressions in the numerator or denominator. And so by direct substitution, we're going to say 3 cosine of 0 minus 0 times sine of 0 all over cosine of 0. So one thing I want y'all to remember is that cosine of 0 is 1. So again, I know I don't need to go over that, but we always want to remember what sine of 0 and cosine of 0 are. Sine of 0 is 0. Remember, sine of 0 is 0, cosine of 0 is 1, okay? 3 times 1, and then minus 0 over cosine of 0 is 1. So this is 3 times 1 over 1, which is 3. So thus, the limit as x approaches 0 of the following x times cosine of x minus 1 over sine of x minus x is equal to 3. And that, guys, is our final answer to this problem. So I know that was a very tedious problem. I'm so sorry if I made a mistake at some point. But yeah, as y'all can see, I also get tricked, or I also mess up. But with that being said, guys, that is how we find this limit by L'Hopital's rule. If anybody does have any questions, please let me know. And thank y'all so much for watching. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.